So glycolysis, and I think they did a great job, so I'm kind of going to re-reference what they said. If you break down the name, you get like an older version of the name for glucose is glycose, and lysis means breaking down. What is breaking down in glycolysis? Glucose. So it's a process where you take 2 ATPs, so that's the investment phase as they referenced, to break down a molecule of glucose. So we need ATP, glucose, and then there's one other thing we need. But that's a good, because that's those NAD, good, okay? All right, what do we make? When glucose is split by ATP, what is made? 2 what? Pyruvates. When NAD breaks off or reacts with something, and we don't need to know this something, what is made? NADH, good. And 4 ATPs are made. So we needed 2 ATPs to make 4, so how many did we really make? 2. Where does all this happen? Cytoplasm. And what kind of organisms can undergo glycolysis? How do we know that? Because all organisms have a cytoplasm. Good job. Try to focus on what I just said without looking at your notes. What do you think is the starting molecule on the top? Who? I heard it. Glucose. Because glucose is, think of G for glycolysis, G for glucose. That is the start of this reaction. What else is needed to make this happen? 2 ATPs. What are they going to do? They're going to break it into what? ADP, which is right here, and pyruvates, which actually go through 2 steps before they become pyruvates. This is this thing called PGAL, and you don't even have to know that, but it's there. So the reaction actually doesn't just happen right away. It's a breaking point. What else do we need? NADs, and NADs are going to make what? NADH. How many ATPs are we going to make in the end? 4. So we're going to make 2 on each end. And the net output is actually 2. One more diagram repeating the same thing. What's this starting molecule? Glucose. Now here's where you actually learn something a little bit different than what I've taught before. Glucose is a 6-carbon sugar molecule. And I think you guys did a great job in representing that. What do we need to break up this 6-carbon sugar molecule? How many? 2. We're going to get 2 ATPs, and we're going to break up this 6-carbon sugar molecule into 2 what? 2 pyruvate molecules, which are actually made up of 3 carbons. You have to know that. So right here where it says pyruvate, you put 3 carbons. And that's not where pyruvate is, but I'll move it back over here. Okay? Now, I just released everything else. I'll just hide them back up. Correct. Now, what else do we need? What is going to be here making this? NAD makes NADH. That's happening on each side. But again, we don't have to know numbers for that. Okay? And ADP will turn back into ATPs. How many? 4. Okay? And then you're left with these pyruvates. Okay? Notice how all this point here, these 3 carbon sugars are not considered pyruvates yet. That because they still have the P attached to them, which is going to go later and form back ATPs. This is where you end up with your pyruvates.